Hello everyone, my name is Jean Paul Tarafa, and on this video I'm going to talk about the final project for the EEEL 2161 programming with C class. So on this slide, which is from my main file, um, you can see how I got the get matrix and the matrix math. Those two are the header files and the C files that I use for each of the options that I prompted the user. Um, so we'll see those ahead, and you can see after that I just initiated my columns for the matrices and the options that I was gonna offer. Having as or prompt for the options, which as you can see are the matrix addition or subtraction, the matrix multiplication, matrix transpose, or finding solutions of simultaneous linear equations. So after we prompted and we printed the options, we did the scanf to get which option he was gonna use, to read which option he was gonna use. So we typed the percentage with the C for character because we use A, B, C, and D, and then the ampersand option, which is what's gonna be registered to. At the bottom, you can see we use the switch option, and our first option, which was addition and subtraction, addition or subtraction, we used the get matrix header. After I called for the get matrix, I printed out the matrix I was given, and right after I print out the matrix, you can see I did the add and subtraction header file, which I called from the um, matrix math shown earlier, uh, which I used to call for the program, and then it would just print out the result that was adding or subtracting the matrices that were given. After looking at option A, we get the result and move on to the option B, which from the project we were asked also to get the matrix. So on the option B, we'll be using the get matrix header file to call for that program and use the matrix for the calculation of the multiplication. So you can see after I call for the get matrix, I got my for loops to print out each of the matrices, and after printing out the matrices, I did the multiplication header file, which is another it's on my matrix math file, which will do the multiplication, and we'll actually check if you can multiply both matrices. So we'll move on to the option C now. We call then the C case, and we started with asking for the row number for the matrices, and after we ask for the row and the column number for the matrices, we go ahead and initiate an I and a J for the for loops, and we create the for loop for them to type in the row and the column elements. So basically, each space of the arrays uh, are gonna be assigned a value. So we're going through each of those spaces just to uh, put value in them, and then set it to the matrix A, which is called on the scanf with the percentage and D for the integer. Then after we got the for loops, and we created another for loop to display the matrix, and then we use the transpose program with the header file and the C file. So that will take care of transposing, checking if they're valid and transposing the values. Then we can go ahead and move on to the case D, which was solving linear equations with the grammar rule. So I started with the for loops. I got a nested for loop, and I was asking for the row and the column elements of the matrix. So on the project, we were given a specific the dimensions, which were 3 by 3. We had X, Y, and Z. So that will be basically why on the for loops the I is going only up till 3, which in this case is 2 because it counts 0, so it's 0, 1, and 2, and that'll be the 3 numbers. So after that, I create another for loop for the B, which will be the X, Y, and Z values. And after I collect those with the for loop and I assign them to the uh, B, I go ahead and use the grammar grammar rule, and which is a program we call from the C file and the header file of matrix math. And then after that we use call the default case, which means anything else after that will print out invalid input. Now on this slide, I can talk about the matrix, which is basically took care of the first two options, which were the addition and subtraction and the multiplication. So we can see that I initiated my A and the J for the for loops. I started by printing or prompting the user for the matrix, column numbers, and row numbers. So we asked for the matrix A, and when we're gonna do it for the matrix B, we start a do while loop. So we ask for the user for the column and the row numbers of matrix B, and we make sure they do that as long as they're not equal. So let's say RA does not equal RB, which means rows of matrix A are not equal to rows of column B, which what we'll do is as long as it's not correct, it will keep asking you until you get something that it is equal, and then it will move to the next step. In this case, that's what we're looking for, because in order to multiply, uh, you will need to check if they are um, equal. So after that, I create a for loop, and with the for loop, I ask for the elements in the matrix. So each of the matrices, we're gonna go on the arrays and fill each spot. And we do that for matrix A and then for matrix B. Now this is the header file that I use. So basically, we just defining the get matrix function that we program on the last file on the C file, and basically the if def. So basically saying if def the get matrix is called, then define the get matrix, and then we use the end if just to basically end the program. Next step I had was the matrix math C file. So this file will contain the program, the same thing with the get matrix header file and the C file. So we started with the add and subtract. We called the um the integers, the rows, the columns, the matrices that we're gonna use, and then we started with the print. So it was gonna ask if it was addition or subtraction, and then it was gonna print out the result. And in case that it wasn't a valid option, it will print out the invalid input, as you can see at the bottom. Then we move into the multiplication. Uh, so in this file, we call the rows, the matrices. We do the for loops, right? And then at the end, we make sure that we multiply the A and B matrices and equal it to the C, and then we print out that C matrix, which will be the multiplication, the result. And then we proceed with the Cramer rule, which we use for the last option. And then we use the det A to basically call for determinant A, which is the first determinant that we're gonna use before using the Cramer's rule. And then we put the determinant X, Y, and Z, which were gonna be the values for the X, Y, and Z that we wanted. And after we use the determinants at the bottom, we call for C, which basically will do the division for the Cramer's rule, and it will print out the answer for the X, Y, and the C. Then we continue with the matrix math header. And so we do the same thing. We if define the matrix math, define matrix math called each of the functions, the add, sub, multiplication, transpose, and Cramer rule, and then use the hashtag NF to end when it reads the functions. Most of this information I got from both of the links below, and those were mostly where I got most of the information I got problem or issues with. Most of my issues were due to when I started the program, I did everything not using defined functions. So everything was in just one file, and I didn't have no header or C file. So then I just use the functions which I had to learn due to having to do the option with the define function. So the link the G for jigs helped me with that. And then another thing was with the Cramer's rule. I didn't have too much knowledge on it, so I used the link and it helped me to see and clarify how to place the matrices. So that was the end of the presentation, and thank you for your attention and your time.